Hi, this is Hejia Zhang. I'm recording this video for UCSD CSE Teaching Applicant application. In this video, I'm gonna teach a basic but important concept of SystemVerilog, which is hardware description. So, I have talked with many of my friends learning computer science, and they have reported to me that SystemVerilog is quite hard for them to learn. Although they have successfully learned C or Python or other different language, but SystemVerilog still appears to be hard for them. And when they apply some familiar concept to SystemVerilog like iteration or branching, the output will always become messy and compilation does not go as they expect. After discussion, I found that this hardness is because SystemVerilog is not describing assembly program they are familiar with, but describing digital circuits. And today we are gonna focus on the difference between these two descriptions and hope this could help you write better SystemVerilog code in future assignments. First, we'll go through some basic examples, like a simple addition. In SystemVerilog, it becomes an adder circuit, not adding assembly instruction like add or move or something else. And a branching operation like assigning B or C into A depend on D's value would become a selector circuit in SystemVerilog. And these are some easy examples that you might be familiar with, but when things get a little bit more complicated, some interesting thing would happen. For example, we have this code trying to calculate the sum of an array B which has four elements. And what would the circuit be like in this case? Some of you might already seen the circuit I have ever drawn on my PowerPoint page. It would be like this. First we have B0 and B1 get assigned into an adder, and the sum being added with B2, the sum added with B3, and got an A. Please pay attention that the difference here is, instead of executing 4 different instructions, we implemented 3 adders here. These adders are physically existent in your FPGA or VLSI. And let's look at another similar example which also computes the sum of array B, but in a little bit different order. If these are C code, the result would be similar, but this is SystemVerilog. So the new circuit would be like, first we have an adder adding B0 and B1, then another adder adding B2 and B3, and these two sums add into A. You can see that although the code is quite similar, but the generated circuits are different and they have different latency. Like this circuit only has latency of 2 adders in together, but the previous circuit has 3 adders. And that's why I think all SystemVerilog coders should be aware of the circuit generated by their code.